Remember, it's important to always review the charts you intend to use for a given instrument flight. Planning and preparation before taking off will make you a safer and more competent instrument pilot. Years ago, Jeppesen introduced a new chart format. It was tested and evaluated by human factors professionals, airline crews, and general aviation pilots. The new chart format is known as the Jeppesen briefing strip format. This program concentrates on the briefing strip format. The briefing strip approach chart format is divided into 4 sections: heading, plan view, profile view, and landing minimums. The information is arranged in a specific pattern based on how pilots review and use the chart data. The last major portion of this chart is the landing minimum section, which outlines the minimum altitude you can descend to on the approach and the minimum visibility required for the approach. Landing minimums usually increase when a required component or visual aid becomes inoperative. Jeppesen charts present this information in a logical sequence. For instance, the lowest minimums for the approach are located on the left side of the box. As you move to the right, the minimums increase. On most approach charts, the minimums table represents 2 groups: straight-in approaches and circle-to-land approaches. On ILS approach charts, the straight-in landing section is further divided into minimums with and minimums without the glide slope. On the left side of the minimums box, aircraft categories are represented by the letters A, B, C, and D. The minimums depend upon the category of aircraft you are flying. The FAA has established 5 approach categories based on an aircraft's approach speed. For the most part, the last category, Category E, is not shown on approach charts since it applies only to military aircraft. The approach speed of a particular aircraft is computed as 1.3 times the stalling speed in the landing configuration at maximum landing weight. Most single-engine general aviation aircraft fall into Category A. The first column of an ILS approach is designated as full. The minimums within this column apply when all components are operational. In this example, no matter what category of aircraft you are flying, you can descend to a decision altitude of 791 feet MSL, which is 200 feet above the touchdown zone elevation. Notice that these figures are labeled DA parentheses H. The DA, or decision altitude, is the MSL altitude at which you must make your decision to execute a missed approach or to continue the approach. The DH, or decision height, is shown in feet AGL within the parentheses. For the full ILS, you also must have a touchdown runway visual range of 1,800 feet, or if RVR is not reported, a visibility of 1/2 statute mile. As you move to the right, you can see how the visibility requirements change for various inoperative lights. If more than one component is inoperative, you must use the more restrictive minimum. For example, if both the runway alignment indicator light system and the approach light system are out, use the minimums listed in the rail or ALS out column. For the localizer, glide slope out, or non-precision approach, the figures are labeled MDA parentheses H. The MDA, or minimum descent altitude, is the MSL altitude below which descent may not be made without visual reference. The H, or height, above touchdown is shown within the parentheses. Sometimes sidestep landing minimums also will be published. Typically, these minimums are higher than for the straight-in runway. This allows you to fly an approach to one runway and then land on a parallel runway. On the far right of the chart are the circle-to-land minimum altitudes, heights, and visibilities. Remember, not all approaches offer circle-to-land minimums. The protected airspace during a circle-to-land maneuver depends on your aircraft's approach category. The airspace ranges from 1.3 nautical miles from the runway end for Category A aircraft to 2.3 nautical miles for Category D aircraft. Remember, if you're flying the maneuver at an indicated airspeed that's faster than the maximum limit of the speed range for your category of aircraft, you must use the higher minimums. Otherwise, you might not have the necessary obstacle clearance. The altitudes in parentheses show heights above the airport. These numbers are not based on heights above the touchdown zone because circling minimums are not referenced to a specific runway. A note on this chart indicates that circling approaches are not authorized east of runway 16 left and 34 right. While there are many reasons for a note of this type to be published, one reason may be obstructions within the circling approach area. Again, it's important to look at some variations within the minimums box. On this approach, there is a decision altitude and height penalty when using a remote altimeter setting. This example shows an approach that doesn't have straight-in landing minimums. Remember, straight-in landing minimums are omitted when the final approach is not aligned within 30 degrees of the runway, or if an excessive rate of descent, generally over 400 feet per nautical mile, would be required between the final approach fix and the missed approach point. On the other hand, you are not prohibited from landing straight in when an approach does not show straight-in landing minimums, provided that you break out in time to position the aircraft and make a normal final descent to the runway. Notice that there are different minimums for this approach depending on whether or not you can identify a specific DME fix. Since it is a step-down fix, once you have identified it and crossed it, you can descend to the lower minimum altitude. As you begin to investigate the different types of approaches, you may encounter Category 2 and 3 approaches. Category 2 and Category 3 ILS approaches use the same basic format as a standardized ILS. However, you must be a Cat 2 or Cat 3 authorized pilot and have a Cat 2 or 3 equipped aircraft to use the approaches. Typically, they have lower approach minimums than a standard ILS and may list multiple decision altitudes based on operator requirements and equipment. For example, a Cat 2 decision altitude is normally 100 feet above the touchdown zone elevation. As a pilot, it is prudent to thoroughly read and understand the profile view of the chart. If there is something noted on the chart that you haven't seen before, refer to the chart legend and the Jeppesen Chart User's Guide for further information. Finally, if any changes were made to the chart during the last revision cycle, they will be noted along the bottom edge of the chart. In this example, the MSA altitude was changed.